So hello, my name is Mark. I work at Facebook. I work in the organization called NetEng, so network engineering. I'm not a network engineer though. Well, my team is responsible for providing systems for synthetic network monitoring. So people who actually know how the internet works, they can just use it and fix things and just improve them. And today, actually, I wanted to talk about something slightly different. Actually, before we actually just go into the building the the network event systems, I guess like this would be also like a good kind of wrap up for what's been said over the course of the 3 days. Because I've seen that like lots of people were talking about like the metrics of observability, latencies, SLO, and all this stuff. And like, yeah, like before, like we all tend to just get this information about like what can we do with this, right? So the first question is really like, do you really understand your systems and what does it mean? So we tend to get all those other metrics, and like why do we even do this? Before even like if we go one step further, like we should probably just realize, so like we know this, but like sometimes we don't realize it. Like monitoring is pretty much everywhere. So like in some factories, whenever we drive, we just check the speed. We have to check whether we have enough fuel, so we're not stuck somewhere in the middle of the road. Or even before, especially here in Singapore, for people coming from overseas, like we check the temperature and then we check, okay, maybe it's like super too hot, or like or in somewhere else, like maybe I should just put on my jacket. So essentially, we monitor things everywhere, right? So there's this very famous phrase which says like, if you can't measure this, you cannot understand this system, whatever. I would just risk saying that you cannot even improve this, because effectively what we all try to do is like improve our infrastructure, make our company be more efficient, make our systems faster, cheaper, so they require less people and so on, right? So yeah, so like the measuring and monitoring is like also important in the long term. And the ways of monitoring, so like the logs, metrics, whatever we use, we all know this, is also the communication layer between us and our systems. Usually this is like I would say, uniform way of communication. So we can just ingest some information, which was and like the way it will be processed. It all depends. Like it's defined during the development phase, and then we pretty much we can just get some data. So, and it's really up to us, or like the developers, how good the data will be, and like how easy we will be able to digest information when the things are actually already running, be it on your your clients' phones, be on your massive infrastructure, and then it really just can just save a lot of time to when the things are actually going wrong. So you may actually ask whether the scale matters. So obviously, there are lots of people who work on the massive hyperscale infrastructures. You may actually ask if this applies to monolithic or distributed systems, and you may actually ask if the backend, if this only applies to the backend systems, perhaps like some frontend again, but like running somewhere in production, or maybe just client mobile system. I would say it really doesn't matter, because even if you think, let's say you have the I mean, it's super obvious for like backend massive systems. However, like if you think about the, let's say you have the, I don't know, iOS app, right, which is like tiny-ish binary, and then you get lucky and successful, and then just dozens of, or like hundreds of thousands of people actually use it across the world. So essentially, if you don't actually measure how it works and like how performant it is, you will get into the edge cases where somebody like in some country on some version of the system, or like with this particular hardware, will probably just have some different conditions, and you cannot really just roll out just application and like hope it will work, because eventually it will start breaking somewhere. So monitoring and like being verbose about what's going on is very, very important pretty much everywhere. So yeah, whys. Why do we even do this? So there were lots of talks about like how we do this. The whys are also probably important. So first of all, I claim like we want to be sure that when things are actually going wrong, we want to know that they are going right. So excuse me, when the things are actually going right, we want to be sure. So we come to the office, we see that metrics are fine, the dashboards are fine, no alarms. We can go have a coffee and perhaps just jump on another project. We want to know when the things are actually going to break. So sometimes it will take some time to respond to this. I know it may be like we are just starting to run out of the capacity in the disks, because we work on the file storage system. Perhaps it will require talking with some capacity planners, or like perhaps we'll have to even start thinking about changing the algorithms or changing the whole architecture. This is our way to actually see that like we will have some troubles if we don't react. The third reason is like, okay, things happen, so we are on fire, 3 a.m., lots of pages, lots of conf calls, chats, and all this stuff. We know that things are going wrong, are wrong already, and we just need to mitigate this, so then the metrics, logs, everything will help us. And we obviously want to avoid the worst thing, so we want to avoid our users reporting, hey, dude, your system is not working, like I got timeouts, like what's going on, right? And then it means like you're probably just out of the budget for your SLAs and so on. And the last but not least, like which I think is also like sometimes maybe a bit forgotten, when the company grows, they pretty much have the vision and like the growth plans for next months, years, and like having a couple of metrics by which we even define the system can help us decide whether we will actually be able to keep up with this growth, given we, for instance, have to. And later, when we are just, having this journey, we can actually check if we are if we're like maybe just ahead of the plan, we have some delays and so on and so on. So that, for instance, like in our case, this would be, in our monitoring case, would be like, okay, how well we can how well do we cover our networks, given that they change constantly and like they grow in exponential growth, and also like how precise we are and things like this. So very first way of like actually systems communicating with us are just logs. So they are probably the most verbose way of system telling us, and like they should probably just walk us through the execution path or like what the system is doing and like whether things are actually okay or they are not going okay. Logs are like this is usually text, right? And it's also very important to kind of know that, or like emphasize, especially during the development phase, that logs should be easy to digest and like should be easy to orientate whenever we are just seeing the system and not the kind of like lines of code and just debugging something, but like when we are doing the proper troubleshooting, and this is something which is running on production, we cannot really change this, and we actually have to fix something because like the system is like losing money, or like just the photos are not being stored. So like obviously not in Facebook, but like I've actually seen a couple of logging like this. Well, good luck troubleshooting this at 3 a.m. We don't even know what went wrong. We just know the binary is not running. If you're lucky and you have access to the source code, you will probably start doing something like this. Well, and you better pray like this something went wrong is actually just as a kind of one line of code, and it wasn't like a line broke or anything like this. Well, this is obviously like if I have seen something on my systems, I would say like go fix this because I'm not touching this. And I think this way of approach is very popular, especially among like junior developers, because they tend to focus on the positive side. So like, well, I would just make a connection, I would just make an RPC, I'm sure it will work. If it doesn't, I would just catch the exception. Then I would just say like, hey, it didn't work, right? But they tend to focus on like, those positive and like it's successful handling of the operations. Yeah, so obviously this is much better and like still not the best, but like much better way of logging. So essentially we know that what's going on. We know at which phase this binary is. We know that like perhaps this service X is actually crucial for working, and we know that like it tried 3 times, it timed out. I'm sorry? Ah, okay. We know it actually timed out, and like at least here we know where the problem exists, and like it might be on our side perhaps, or perhaps we should just reach out to service X on call and like say and ask them like, why do we see timeouts? So here like the way the logs are actually being structured is like much more defined and better. So monitoring at scale, obviously like we cannot really read all the logs. We don't want to stare at them all the time. And there are like lots of projects and lots of internal systems for processing those logs, for transforming them especially into the time scale, time series data points, because we cannot really read all the logs, and we don't even want to do this, right? Also, like that's why this also brings us to metrics. So one of the the way of, I mean, many projects like try to aggregate logs and perhaps eventually produce some sort of metrics, or we can just start logging by providing some metrics. So essentially, metrics will give us some kind of like numbers. We like numbers. We can just apply some mathematical functions of numbers. We can find, we can look for anomalies, and we can build graphs. So we will have like things going up, things going down. And somehow people like since the ancient times they pretty much love the pictures, and they prefer them than reading some letters and things like this. Metrics are also very good because they tend to give us they allow us to see the trends. They also allow us to actually like have some sort of ramifications of our system. So they allow us to actually have the 10,000 meters view of the system, and it was mentioned on one of the talks that, and I completely agree with this, that like very often when we have like a huge system which internally just there are like multiple moving parts. Essentially, what our customers care is like, okay, when I send the request, do I get the response in a timely manner, or like can I be sure that this request will be like safely stored on the storage and like it will never disappear and things like this. And like somebody also mentioned that like you may actually see like multiple different parts which seem to be okay, but like when you actually combine them all, you will see that well, the system as a kind of black box doesn't really work well. So metrics and like combining those metrics, comparing and like finding the correlation can help us like looking at the system as a one piece of software which does one thing, right? Also, the other thing, which something we also tend to do very often on Facebook, is like putting the systems into ramifications. So like of the metrics. So number of different, like what's the coverage, how precise the signal is for instance, for the monitoring, and then we actually make sure that we don't have any regressions. We make sure that we pretty much align with like the plans, the visions for growth of our network, for our infrastructure, and so on. Okay, so like now let's say that we have those metrics. We know whether the system works. We kind of understand it. We know how to correlate those signals. We also know that things eventually will go wrong, like if they haven't gone wrong already a couple of times, right? So how do we respond to this? At scale, like manual reactions are actually like having all those manual reactions is practically impossible, meaning that there are obviously like lots of incidents or the failures where like human interaction is actually required, but on the other hand, there are lots of incidents which are like well defined, and we know exactly how to respond to them. So very often we tend to quote ourselves that, or like to repeat that we try to automatize ourselves from the job. So why don't we actually just start programming around those well-defined problems, and since we already know how to fix them, right? So internally in our infrastructure, we have a couple of systems to do this. And since I work reasonably low in the whole stack of infrastructure, so it's more like about servers and especially even network devices. We have systems which are basically called like STAR, AR, so automatic remediation, and those systems are responsible for like taking out the devices out of network. So we call them draining them, or like just removing the hosts from the network and just sending them to repair, or like try to re-image those machines, and pretty much just responding to the faults and directly in the machines. Now. We thought that like it would be good to actually also like share a couple of practices, out of the company. But on the other hand, like decoupling those systems with from our infrastructure would be very, very hard. So at some point, like my colleague and a couple of other people in NetEng especially, we thought that like maybe we can just make a educational demo for so we could just pretty much open source, and also like it wouldn't be really tied to the network, to the Facebook infrastructure. So you don't really need to be inside Facebook, and you can just spin it up on your computer or even on a couple of on your machines, and like see, maybe you will just learn something, or just if you don't have it yet, you can just try it out internally. Yeah, so when we were just doing this, we thought, okay, so let's not make it like a fully featured thing, like we because like it would be like overkill probably, but like we can just think about like a very simple architecture, and again have this more like as a kind of proof of concept. So another need was make it this highly scalable. I would say it's more like highly scalable, because I wouldn't run the hyperscale company on this. But on the other hand, it should actually cover most of the cases in a reasonably smaller infrastructure. It should also be modular, so it shouldn't be tied to the technology that was used. It was actually used. We actually used Go because it fits the infrastructure, as you probably know. But like you shouldn't be really tied to the to this particular language. Also, like the other reason was like that, especially network engineers, they tend to they tend to like other languages, especially Python, and probably even sometimes Perl. I don't know if anybody is using Perl here, but like that's why like the kind of way of architecting it was done this way. Okay, so how does it work? So basically, the project is called GoAR. It's like Go automatic remediation. Somebody really wanted to put the Go in the name. Honestly, it wasn't me. And they had like a huge battle around this. I lost, apparently. However, like it's on our Facebook GitHub. I'll share the link later on. However, like okay, so how does it look like? What's the pipeline around this? So essentially, the system is like a distributed pipeline where something happens, some incident happens, and like the data comes on the left, and essentially as a kind of well-defined response or reaction will be executed like on the right of this pipeline. You can see that there are multiple components. They are glued by probably the most popular open source message broker, RabbitMQ, because again, like then everybody can use it, and you don't need internal proprietary queuing systems. Yeah, in terms of scaling, like the way we actually split those things into multiple, the reason why we actually split the whole pipeline into multiple components is that you should be able to scale up by just throwing a bit more resources. Obviously, this is not the this is not the ultimate way of scaling up the projects, because at some point you probably it's throwing just machines is not enough. However, like usually the practice helps that like to some degree, like just having the reasonably scalable architecture and just adding more machines will really help, and like this should be enough. So what are the building blocks? I already just showed you the common pipeline, and then we will see like again the building blocks. So first of all, we've got the tailors. Tailors are pretty much responsible for digesting and understanding the data from the outer world. So tailors is the place where they actually know like, okay, I have to just open this file, I have to just query this file, maybe I have to connect to this database, and I know that this will be this table, I need to just execute this select query, or perhaps the tailor will just expose the RPC service, so somebody just with the CLI can just make an ad hoc call and then trigger some sort of remediation or audits, and I will talk about this later. So tailor pretty much translates the external formats to the internal blobs, so the rest of the pipeline doesn't really have to bother with like files, databases and things like this. So next we have the processor, which matches rules to a given incident. So essentially we know each processor has the configuration file where you have defined rules, and it says, okay, if this happens, I got this request from the tailor, this means that I should apply, those actions, right? And essentially, in the most simplistic way, the most simplistic implementation, it pretty much just matches the given rejects from the incidents, which are again fed or dispatched from the tailor, and then the first that match, then the rule will. The first rule that matches the first rule wins, and then the processor is actually dispatching a request to executor to actually execute the audits or the checks. Internally we call them audits, or the remediations, or just the jobs. So the checks would be typically we would have like a pre-checks and post-checks, meaning like sometimes even when we want to just fix something, let's say drain the device, so essentially like take it out from the network, so it's not forwarding any packets. Perhaps we cannot just drain all the devices in a given cluster or pod because then we wouldn't have the capacity to actually serve the traffic to this pod. So pre-check is like actually prerequisite for the job to be successful, given it's actually defined. And the post-check will be like, well, okay, we did this job. It says it's okay, but like let's double check it's actually okay. And the job and the remediation is pretty much the execution of kind of healing of or direct response to this incident. Yeah, and to give you again, the example of how the system could actually work. So let's assume that we have some sort of incident which happened on the network. So and the tailor is actually just constantly like getting messages from the syslog server in our infrastructure. So essentially like one line like about the the one of the interfaces on the router is actually being down. So we know that we should actually respond to this by just running some checks. Then the tailor dispatches the dispatches the request to the processor, which tries to match the rules. And like one of the rules that it finds is the it's called interface down Arista. Arista is like one of the vendor for the routers, and it knows that it's supposed to actually run like one pre-audit and one remediation. And it's actually it's perhaps a bit too small, but like you can see that the diagonals port down.py and the port down.py, well, they are pretty much like Python scripts. What's happened next? Processor is actually dispatching the request to the executor. It's also responsible for like for defining like which device we actually have to really query and like do like run all the pre-audits and remediations, because and then it also gets this from the initial syslogs from the tailors. Now just like I said, the system is modular enough, especially for network engineers, so they can also like run Python, Shell, C++, whatever language they want. And the way it was actually architected is that Executor is going to create the separate process and execute the binary along with the parameters which are pre-calculated by the processor. And processor obviously takes those parameters from the request from the tailor. And initially, this comes also from the logs or different external information from the tailor. Executor is responsible, obviously, for like maintaining that the process is it's not styling. So like it will also kill the process once the timeout response. And the only potential change that needs to be done to actually integrate those remediations or the checks with the executor is a sort of contract where each process, so like in this case would be diagnosed port down.py or like port down.arista.py. Needs to output the well-defined and like described in the documentation the JSON blob with the description of like, okay, so like I did what I was supposed to do. I didn't have any problems, or like should the exceptions actually be raised? Like the whole job wouldn't be also successful. And then Executor, by just parsing those information, will know that, like, okay, I should either just report this as a successful job and just go on and execute the post audits to actually, you know, double check that the remediation was done successful and the state of our infrastructure is as we expected, or like perhaps it should also just requeue everything so we can just retry until the you know, the configured parameter, or it should pretty much just stop doing this because and just report to the operator or like to the database, because apparently there is some sort of circumstances. There are some sort of circumstances where, you know, we cannot do the remediation, and this is something where the operator should take a look at this. So we went from the incident to the remediation, and like without really human intervention, like we can all sleep or just having coffees or just focusing on something much more interesting. So if you're interested, like this is on our GitHub. As again, this is sort of like a educational approach to auto remediation of events. We don't use this in production. However, like you know, some of the ideas were taken from our production systems. If you're interested, you know, you can just go ahead and just check out the code, or like pull requests are also like welcomed. And yeah, this is all for me. Yeah, thank you. Sorry?
I have time for a couple questions.
Hey, so is this like an updated version of FBAR or a completely different system?
Well, yeah, so we use FBAR internally. I would say this is like the sibling of FBAR, and like, well, it's not as fully featured as FBAR, because FBAR it's more advanced. This is much way simple.
Got it. Thanks.
Mm.
Thank you.
Thank you.